Hello everyone, welcome to Nature Academy and this is Dr. Atahar Parveen. In the previous lecture we saw how to solve first order linear differential equation of the form dy by dx plus py is equal to q. But how will you solve this type of equation? See the equation carefully. Here dy by dx is not given. They have not given directly, they have not given directly in the question. We will have to rearrange this differential equation so that I have dy by dx in the equation, and that differential equation will be of the general form dy by dx plus py is equal to q. Then I can proceed with the finding of integrating factor and then the solution of differential equation as we have done in the part 1 of this chapter. So rearrange the given differential equation like this. Take dx common in the second, third and fourth terms so that we can write x into dy plus 3x cube y minus x square into dx is equal to 0. Now I can further rearrange as x into dy minus y into dx is equal to x square minus 3x cube y into dx, or I can also write as x into dy minus y into dx is equal to, I will take x square common so that I have x square into 1 minus 3xy into dx, and then I can bring that x square in the denominator in the left hand side and write it as x dy minus y dx by x square is equal to 1 minus 3xy into dx. Here I would recommend you to pause the video for a while and think what will be the next step. Then come back and play the video and then proceed with the sum. This x into dy minus y into dx by x square in the left hand side, it is actually in the form of u by v whole dash. This is a division rule in the differentiation. See, it is like u dash v minus uv dash by v square. This is equal to u by v whole dash. Actually, when you differentiate u by v, you follow this formula. Now here in this given equation, we have u will be y, then u dash will become dy, v will be x, and v dash will become dx when you differentiate it. So I can simply write this equation in this form now, so that I have y by x whole dash is equal to, my right hand side is not going to change, 1 minus 3xy into dx. Okay. Now to make this differential equation more simpler, what I am going to do is, I will put y by x is equal to z. When I write y by x is equal to z, it means that my y will become x into z, or x into y can be written as x into xz, and the value of xy will be z into x square. So keeping this in mind, that my y by x is z and xy is zx square, I can write this equation 1 as dz by dx is equal to 1 minus 3zx square, or I can also write it as dz by dx plus 3zx square is equal to 1, which will also imply that dz by dx plus 3x square z is equal to 1, or this is in the form dy by dx plus p into y is equal to q. Here y is z. Therefore, what will be my dy by dx here? So dy by dx is like dz by dx, and p is like 3x square here, and q is 1. So using this data, I can find the step 2 of my integrating factor, because this is the general form now. This is the general form of linear differential equation. So my step 2 will be to find the integrating factor, which is equal to e raised to integral p into dx, or e raised to integral 3x square into dx, which I can also write as e raised to 3 integral x square dx. And we know that integral x square is x cube by 3. So I am going to integrate it and write x cube by 3 here. This is equal to 3 and 3 will get cancelled, e raised to x cube. So this will be my integrating factor. Now what is the step 3? Step 3 is to find the general solution for this differential equation. So that will be equal to my y into integrating factor is equal to integral q into integrating factor into dx plus c. But be careful, here in this equation we have taken y as z. So our equation will be z into integrating factor equal to integral q into integrating factor into dx plus c. So just write down what is the value of z here. We have taken z is equal to y by x, and integrating factor we got e raised to x cube, that is equal to integral q is 1 and integrating factor is e raised to x cube into dx plus c. Now this is the solution for this differential equation. If you want to further evaluate this integral e raised to x cube, we have this exponential power series, because you cannot easily integrate this like that only. It is not possible. So you have to use the exponential power series, which says e raised to x is equals to summation n is greater than or equal to 0 x raised to n by n factorial. Further, if there is a need, you can use this equation of power series of the exponential, and by using gamma function you can calculate that integral e raised to x cube. Anyway, this is the general solution for the differential equation. So the main motto of this problem was that how to solve a differential equation when dy by dx is not given. If dy by dx is not given, then also we can easily solve the differential equation. That is how I showed in this problem. Now let us move on to previous year questions. The first question is dy by dx plus y tan x is equal to cos x. Now this is a GATE 2017 question, and the condition here, the initial condition is that if y is equal to 0 at x is equal to 0, what is the value at x is equal to pi by 3? And the options are pi by 3, pi by 6 and 0. Now for this, you can easily identify that this is a linear differential equation because it is already in the general form. So you can skip step 1 and you can directly come to step 2. And what is that step 2? Finding the integrating factor, which is equal to e raised to integral p into dx. But in the given equation, what is p? P is tan x. Because see, this will be p, this will be q, and dy by dx is as it is. And our q will be cos x. So this has become very simple for us now. So I can find integrating factor is equal to e raised to integral. In place of p, I will write tan x into dx. So my integrating factor will become e raised to integral tan x will be log of secant x. So I am going to write it like that, secant x. And my log and exponential will get cancelled. So my integrating factor will be secant x. So let's keep this in mind about the integrating factor and move on to find the general solution of this equation. The general solution, this was my step 2 and this will be my step 3, the finding the general solution. So the general solution is y into integrating factor is equal to integral q into integrating factor into dx plus c. Now my integrating factor is secant x. This will be equal to integral q is cos x and integrating factor is secant x into dx plus c. Now I have y into secant x, which can be written which is equal to integral cos x into secant x. I can write it as 1 by cos x into dx plus c. My cos x and cos x will get cancelled and my equation will become y into secant x is equal to integral dx plus c, or y into secant x is equal to x plus c. So let this be 1. Now the given initial condition is that y is 0 at x is equal to 0. So I can find c by substituting the values of x is equal to 0 and y is equal to 0. So therefore y means there is 0 here, and secant of 0 is equal to 0 plus c. Anyway, the value of c is going to be 0. Now put this value of c in equation 1. We get y secant x is equal to x. Now our actual question was to find the value of y at x is equal to pi by 3. So I have to substitute x is equal to pi by 3 in this equation 2 now. So y secant x is equal to, in place of x I am going to write pi by 3 is equal to pi by 3, or y into, what is secant pi by 3? Actually, what is pi by 3? Pi by 3 is 60 degree. So we know that cos 60 is equal to 1 by 2, that is half. Then what will be secant 60? It will be 2. So in place of secant pi by 3, I can write 2 directly. This is equal to pi by 3. Or y is equal to pi by 6. And we have pi by 6 in the options. Yes, of course we have it. And the option is C. So this problem was very simple when compared to our previous problem, isn't it? So it's better that we don't have phobia in our mind that only tough questions are asked in exams. Many times easy simple questions are asked, but they want to just check our IQ, or they want to check how much we have understood the subject. So we don't need to worry that the tough sums will be coming in the exams. Only thing is we need to be strong with the basics, and we should know the procedures and the required formulas. That is more than enough when you attend a competitive exam. Okay, let's move on to next sum. This is a CSIR 2017 question. The function y of x satisfies the differential equation, and the differential equation is given. It is x into dy by dx plus 2y is equal to cos pi x by x. If y is equal to 1 at x is equal to 1, then the value of y at x is equal to 2 is, the options are pi 1, 1 by 2 and 1 by 4. So let us see first the differential equation, how it looks. Does it look like a general form? Yes, it looks. Only thing is I have to little bit rearrange it. So let me rearrange it. That will be my step 1. I will divide this differential equation by x, so that I get dy by dx plus 2 by x into y is equal to cos pi x by x square. Now this differential equation is in the form dy by dx plus p into y is equal to q, where p will be my 2 by x and q will be cos pi x by x square. Now it is very simple for me. Step 2, I will just find the integrating factor for this linear differential equation. The integrating factor is equal to e raised to integral p into dx. So e into integral, value of p is 2 by x into dx. And if I have integral 2 by x into dx, I will take 2 outside because it is a constant. I will have 1 by x dx, and this will be 2 log x. So I will write the 2 log x here in the place of the power of exponential. It is 2 log x, or I can also write it as e raised to log x square. Log and e get cancelled, and this will be x square. So my x square is the integrating factor for this differential equation. Now keeping this in mind, I can easily do the step 3. Step 3 is just to find the solution for the given differential equation, and that is y into integrating factor. This is equal to integral q into integrating factor into dx plus c. So let's just substitute the integrating factor, which is x square. Value of q is cos pi x by x square. This we will keep in mind, and then let's proceed. So it will be y into x square is equal to integral q was cos pi x by x square, and integrating factor we got is x square into dx plus c. Now x square will get cancelled in the right hand side. I have y into x square in the left hand side. This is equal to integral cos pi x into dx plus c, or y into x square is equal to cos pi x is sin pi x. So I can write integral of cos pi x is equal to sin pi x by pi plus c, or y is equal to sin pi x by pi x square plus c by x square. So this will be my equation 1. Now in the question they have given that when x is equal to 1 and y is equal to 1, we can therefore find value of c. So write x is equal to 1 and y is equal to 1 in equation 1, so that you get 1 is equal to sin pi into 1 by pi into 1 square plus c by 1. Sine of 180 degree is equal to 0. So therefore this entire thing is going to become 0. So my value of c will be 1. Now put this value of c in equation 1, so that you get y is equal to sin pi x by pi x square plus 1 by x square. Now the equation for us, the question is we have to find y at x is equal to 2. So put x is equal to 2 to find y. X is equal to 2 implies y is equal to sin 2 pi by 2 square is 4. It will be 4 pi plus 1 by 2 square is 1 by 4. Or y is equal to 1 by 4, because sin 2 pi is also equal to 0. So the value of y will become 1 by 4. Do we have this in the options? Yes, we have. It is option D. It is the right answer. Now moving on to the latest question from the previous year. It is a 2019 question. The question is, the solution of differential equation x into dy into 1 plus x into y is equal to e raised to minus x with the boundary condition y is equal to 0 at x is equal to 1. Now they have also given the options, and the options are x minus 1 by x into e raised to minus x, and option B is x minus 1 by x square into e raised to minus x, and option C is 1 minus x by x square into e raised to minus x, and option D is x minus 1 whole square into e raised to minus x. Seeing the differential equation, it clicked in our mind that okay, this is the linear differential equation. This little bit it looks like a general form, that is dy by dx plus py is equal to q. We have to just rearrange it. So let us rearrange it in step 1. I can write it as just I will divide it by x. If I divide it by x, I get the equation as dy by dx plus 1 plus x by x into y, that is equal to, I will have 1 by x in the right hand side now, into e raised to minus x. Now this is in the form dy by dx plus p into y is equal to q, where p will be 1 plus x by x, or I can also write it as 1 by x plus 1 to make things simpler. See, always our motto should be to simplify things. As much as possible, if we simplify, then only our time is going to save and we are going to get a right answer very fast. And here q is equal to 1 by x e raised to minus x. Now when we have p and q and we have rearranged this into a general form, I can easily find the integrating factor of this given linear differential equation, which is equal to e raised to integral p into dx, or e raised to integral value of p is 1 by x plus 1 into dx. See how easy it has become now. If I had 1 plus x by x in the integral, I would have panicked to integrate it. It will be tough for me. I would have thought like that. But only because I have simplified and I have splitted the terms, it has become very easy to integrate it. So what will be the integral? It will be 1 by x plus 1 into dx. The integral of this will be very simple. It will be, if I split it, it will be 1 by x into dx plus integral 1 into dx. And what is integral 1 by x dx? It is log x plus x. That's it. So that would be my answer here. This is equal to e raised to log x plus x. I can again further split it because there is an exponential, so I will utilize the exponential as much as possible. I can write this additive property into the multiplication. I can write it like this also. Or here if I cancel log and e, I will have x here into e raised to x. So my integrating factor became x into e raised to x. Now I can move on for step 3 very easily. So the step 3, so let us keep this in mind that the integrating factor is x into e raised to x. And we have q is 1 by x into e raised to minus x. So the step 3 will be finding the differential equation solution using our short trick which we have learned in our previous class, plus c, then y into integrating factor was x into e raised to x. This is equal to integral q was 1 by x into e raised to minus x into integrating factor is x into e raised to x plus c. Here x and x will get cancelled, and in the left hand side I have y into x into e raised to x, that is equal to integral e raised to minus x plus x, and I have plus c here. This both will get cancelled and I will have e raised to 0 in the right hand side plus c. But we should know that e raised to 0 is equal to 1. Therefore, I will have y into x into e raised to x is equal to 1. In place of e raised to 0, I am going to write 1 into dx. So, we had dx here, isn't it? We had dx everywhere plus c. So, this will be equal to integral 1 into dx will become x plus c. This is my y into x into e raised to x. So let this be equation now. Equation 1 now. Now let us find c using the initial conditions. What are the initial conditions? The initial conditions are that y is equals to 0 if x is equal to 1. Okay. So I can easily find now. I will put x is equal to 1 and y is equal to 0 in equation 1. So that I get 0 into 1 into e raised to 1 is equal to 1 plus c. Now e raised to 0 is 1 and e raised to 1 is 0. So here things will become 0 and you have 1 plus c here, or the value of c will be minus 1. Now put this value of c in equation 1 so that you get y into x into e raised to x is equal to x minus 1. Or you can also write it as y is equal to x by x into e raised to x minus 1 by x into e raised to x. Now x will get cancelled and I have 1 by e raised to x minus 1 by x into e raised to x. See the options, do they match anywhere? No, the options, they are not matching. I feel that I have to simplify further in order to find the match with an option given in the question. So let us simplify. This I can also write it as e raised to minus x minus e raised to minus x by x, or I can take e raised to minus x common now and write 1 minus 1 by x, or e raised to minus x into x minus 1 by x. So this will be my solution and I cannot further simplify. Let me see if I have a match now. It is e raised to minus x into x minus 1 by x. Do we have it? Yes, we have. It is e raised to minus x into x minus 1 by x. So the option A is the right answer.
At this point, I have a question for you. Have you noticed that we are not writing integration constant while integrating the integrating factor? Because even though we write it, it is going to cancel. As we are using this integrating factor to find the general solution, we are using it both in left hand side and right hand side. So that's why that c which comes in the left hand side and in the right hand side, it is going to cancel. That's why we are not writing it. But writing integration constant while integrating is a must. So this is a tip, and I think you should remember this even if you are a teacher or you are a student.
You can find the notes of this lecture and the part 1, both the part 1 and part 2 lectures of linear differential equation in Nature Academy's website. Please do visit website and download the notes so that it will be easy for you to work out the problems. The link of the website will be given in the description. Okay students, this is how we can do linear differential equations by following the 3 steps and using little bit logic in order to simplify the equations so that we will match with the given options for the general solution or whatever the question is asked with the boundary conditions. Okay, that's all for this lecture. Thank you.